Alright, today we're going to go over analyzing a heating and a cooling curve. But before we look at any of the questions, we want to make sure that we know how to read and interpret this. So we're going to first start with analyzing what our graph is telling us and marking it up. So with that, here we go. So you need to realize that these slanted lines right here, these are the states of matter. So this is the different states, the solid, the liquid, and the gas. So let's go ahead and mark it up. So from A to B, we have a solid. That's because our temperature is the lowest. Up here, between C and D, that's where we have our liquid. And then up here, E and F, that's where we have our gas. Now we're going to go back and talk about how these matters change their state. So that's during this plateau. So whenever we are going from, we're increasing in the temperature, this isn't working. As we increase our temperature, I'm just going to go with this one. As we increase our temperature, we're going to go right. This is melting. When we continue to go, our liquid turning into a gas is boiling. It could also be freezing, or evaporation or vaporization. So whenever we're starting at our gas and we're reading backwards, our gas is going to transition into a liquid. That is condensation. Condensing, and we continue to cool our substance down, our liquid is going to turn into our solid through freezing. That looks pretty bad, but you understand. Save that for later. So what does the information on this graph tell us? Well, the information on this graph, it tells us how the states of matter change. So how temperature influences the states of matter. Let me just make this adjustment. So the graph tells us how temperature influences states of matter of different substances. On our graph, it doesn't tell us what the temperature is, it just says temperature. So we don't know what substance it is. It just is a substance. So number 2, as we read from left to right along the x-axis, what happens with time? Well, if we're looking at the x-axis, if we read it from left over here to right, time is increasing. If we read the graph from the bottom to the top, we can see that the temperature also is increasing. So number 4, ask what state of matter is represented with line segment AB. Well, if we're looking over here, we already marked it up. AB is a solid. What do the particles look like inside of a solid? Well, inside of a solid, all of the particles are very tightly packed with very low energy. According to the graph, what state of matter do we have line segment CD? Over here on CD, we have a liquid. How would you describe the arrangement of atoms in this state of matter? Well, the atoms inside of a liquid, they are loosely packed with some energy. Next, what state of matter do we have with line segment EF? EF is over here. bring this over. Here we have our EF, and our EF is a gas. So next is, how would you describe the particles in the gas? They are very, very far apart with high amounts of energy. So next question asks, what change of state is represented from B to C? This is why it's called a heating and a cooling curve, because you can read this graph from left to right. You could also read this graph from right to left, and you can see that it could heat or cool. So if we're starting at B, B is a solid transitioning into a liquid. That is called melting. Whenever you have your C, your liquid, and then you're going to B, your solid, that is freezing. If we are reading it from D to E, that is boiling. It's also vaporizing and evaporation. And then from E to D is condensing. That's it for the front. So we're going to flip it over, we're going to go to the back, and we're going to mark this graph up. I'm going to zoom in a little bit. We're going to do the same thing. We're going to mark up our graph with things that we know. Again, remember, the slanted lines are our states of matter. So we have our solid, our liquid, and then we have our gas. As we're adding heat, this is melting. We're adding heat. Our liquid is going to vaporize or boil into a gas. If we're cooling our graph, our gas is going to condense. And if we continue to cool our graph, our liquid is going to freeze. Now we're going to use this information to answer these questions. Number 11 says, at what temperature does the substance melt? Well, if we look at the melting line, this line right here where it's transition between a solid and a liquid, that is happening at 0 degrees Celsius. At what temperature does the substance evaporate? So we're going to go to see where the substance is transitioning from a liquid to a gas. That's boiling, evaporation, or vaporization. This plateau happens at the temperature of 100 degrees Celsius. So this is 100 degrees Celsius. At what temperature does the substance condense? You're going to find where a gas is turning into a liquid. That's at this plateau. This plateau occurs at the temperature 100 degrees Celsius. So that is the condensation point. Next question is asking, at what temperature does the substance freeze? Well, the freezing plateau is here, and that also occurs at 0 degrees Celsius. So we should be able to see that whenever the substances transition, it does so freeze and melt at the exact same temperature. Whenever it boils or transitions from a liquid to a gas, it does so at the same temperature that a gas turns into a liquid. The next question asks, what state of matter do you have at 50 degrees Celsius? So you would look at your graph, you find 50 degrees Celsius, which is right here, go over, meet your graph. What state do you have? We have a liquid. What state of matter do you have at 110 degrees Celsius? Come up on the graph, find 110. Where does it meet the graph? Right here, and that state is a gas. What state of matter do you have at negative 10 degrees? So we find negative 10, it meets the graph right here, where we have a solid. So what this graph is telling us today is a physical property of matter. It's physical because if it's a solid, a liquid, or a gas, we still have water molecules. The next question is asking, why is it flat? So if you look up at your graph, we see that we have these flat points. A flat line here and a flat line over here. So the reason why there are these flat lines in both these places is because it takes time for the particles to either speed up to all be the more energetic state of matter or to all slow down. So it takes time. So it takes time for the particles to either speed up or to slow down as they transition between states of matter. All right, that's your lecture for today. Hope you enjoyed it.